This video will cover beginner part 1 questions regarding the topic of derivatives chain rule. Before we start, let's first figure out what to do with the chain rule. Since the first 4 functions can be differentiated using the power rules we have already learned, there is no need to use chain rules. Look at the 4 composite functions on the right. For the first function, rather than using product rules, it would be better to simplify first and then differentiate, but it's a little annoying. How about the other 3 functions? We can simplify the value inside the roots or brackets. In these cases, we use what is called a chain rule. We will now cover how to use the chain rule with the composite functions. These are composite functions. Think g of x equals u. So f of u equals u cubed. So f of u equals u cubed. F of u equals square root of u. F of u equals square root of u. Then f of u equals 1 over u to the power of 4. F of u equals 1 over square root of u. Of course, you can create more complex composite functions, but it's a good idea to think of the simplest shape. So u equals x squared minus 4. Then in a function u equals 3x cubed plus 4x. And then u equals 1 minus 3x squared. The last one, u equals 2x minus 1. Shall we differentiate y equals 3x plus 4 squared? The first way, use the product rule. So we can rewrite as 3x plus 4 times 3x plus 4 dy dx equals 3x plus 4 prime 3x plus 4 plus 3x plus 4 times 3x plus 4 prime. The derivative of 3x plus 4 equals 3, then times 3x plus 4 plus 3x plus 4 times 3x prime equals 3, 4 prime equals 0. So we can simplify 6 of 3x plus 4. The second way, expand first. We can use a plus b squared equals a squared plus 2ab plus b squared. So y equals 3x plus 4 squared equals 3x squared plus 2 times 3x times 4 plus 4 squared, 9x squared plus 6 times 4, which is 24x plus 16. Then dy dx equals 18x plus 24. So common factor 6 take out, 6 times 3x plus 4. The third way is to use the chain rule. Use substitution. Let u be 3x plus 4. Then with these two, we can rewrite as y equals u squared, then u equals 3x plus 4. As you know, y prime can be rewritten as dy dx with the y in respect to x. But now y equals u squared, so y with respect to u, dy du equals 2u, and du dx equals 3, because u with respect to x. Confused about this part, right? Let me explain again. If y equals x squared, then dy dx equals 2x. If y equals u squared, then dy du equals 2u. If y equals t squared, then dy dt equals 2t. Back to the original, dy dx can be rewritten as dy du times du dx. Don't cancel du, we just made it. dy du equals 2u times du dx equals 3. So 6u, but actually u was 3x plus 4. We have the same answer. Think about the composite function y equals u squared. Don't forget this one. We differentiate out the function first. dy dx equals 2u out the function, and then multiply the differentiate of the inner function u prime, which is 3. So 2u times u prime equals 3. Then 6u equals 6 times 3x plus 4. Was it harder than you think? You might just want to use the first or second way. But if the problem to be differentiated is y equals 2x plus 1 to the power of 13, or y equals square root of x plus square root of x plus square root of x. So let's change your mind about giving up and get ready to run. We just did the first way. Let me explain again in the second way. Y equals 3x plus 4 squared, then f of u equals u squared, then u equals g of x equals 3x plus 4. So f of g of x equals 3x plus 4 squared, then f prime of g of x times g prime of x means differentiate out the function. So 2u, differentiate out the function and keep the inner function, times differentiate the inner function. So think 3x plus 4 is here. Then 2 times 3x plus 4 times the derivative of the inner function is 3. So final answer is 6 times 3x plus 4. So this is the general power rule. When you see y equals 3x plus 4 squared, then y prime equals, think u squared. So outside first, 2 times u, 2u to the power of 1, then times, keep the inner function, prime, 3x plus 4, 3x plus 4. So 2 times 3x plus 4, then times 3x plus 4 prime, which is 3. Final answer is 6 times 3x plus 4. This is the first question. Use the substitution. Let u equals 2x plus 1. That means y equals u to the power of 5. Then u equals 2x plus 1. Then dy du equals 5u to the power of 4. Then du dx equals 2. So dy dx equals, we can rewrite as dy du times du dx. dy du is 5u to the power of 4. Then du dx equals 2. So 10u to the power of 4. But u was 2x plus 1. This is the final answer. Second way, think this way. Y equals u to the power of 5. Then dy dx equals 5 u to the power of 4. Then u prime. So dy dx equals 5 u to the power of 4 times u prime. Keep the inner function, 2x plus 1. So keep the first one, 5 times 2x plus 1 to the power of 4. Then 2x plus 1 prime equals 2. Then 10 times 2x plus 1 to the power of 4. we have the same answer. This is the next question. Let u equals x squared plus 3x. So we can rewrite as y equals square root of u, which is y to the power of 1 over 2. Then dy du equals 1 over 2 e to the power of 1 over 2 minus 1, 1 over 2 e to the power of minus 1 over 2. We can rewrite as 1 over 2 square root of u. And then u equals x squared plus 3x. So du dx equals 2x plus 3. Then dy dx equals dy du times du dx. So 1 over 2 square root of u times 2x plus 3. U was x squared plus 3x. Then 2x plus 3 over 2 square root of x squared plus 3x. Or we can rewrite as x squared plus 3x to the power of 1 over 2. Think y equals u to the power of 1 over 2. Then dy dx equals 1 over 2 e to the power of minus 1 over 2. Derivative of outer function, then derivative of inner function. Back to the original, dy dx equals 1 over 2 u to the power of minus 1 over 2 times u prime. Keep the inner function x squared plus 3x. And 1 over 2, we can rewrite in radical form. 1 over square root of x squared plus 3x. Then x squared plus 3x prime equals 2x plus 3. So we can rewrite as 2x plus 3 over 2 square root of x squared plus 3x. Some students say they like the first method. By the way, the easy problem doesn't matter, but if the problem gets much more complicated, the second method is much more convenient to use. Number 3, we can rewrite as y equals 4 minus 2x cubed to the power of 2 over 3. Think this way, y equals u to the power of 2 over 3. Use the power rule, dy dx equals 2 over 3 u to the power of 2 over 3 minus 1 times u prime. Then back to the original, dy dx equals 2 over 3 u to the power of 2 over 3 minus 1 times u prime. Then keep the inner function 4 minus 2x cubed. So keep the first one 2 over 3, 4 minus 2x cubed to the power of minus 1 over 3. Then 4 prime is 0, minus 2x cubed prime equals minus 6x squared. Then we can simplify 3 times 1, 3 times 2, minus 4x squared times 4 minus 2x cubed to the power of minus 1 over 3. Then you can rewrite as minus 4x squared over cube root of 4 minus 2x cubed. This is the last question. We can rewrite as y equals minus 5 times x squared plus 2 to the power of minus 3. Use the power rule, the derivative of the outer function first. Dy dx equals minus 5 times minus 3 is 15 to the power of minus 4. Then times derivative of the inner function. Keep the inner function x squared plus 2. Then 15 x squared plus 2 to the power of minus 4. X squared plus 2 prime equals 2x. Then simplify 30x times x squared plus 2 to the power of minus 4. Then we can rewrite as 30x over x squared plus 2 to the power of 4. I hope this video has been helpful. If you have any questions, leave them in a comment below, and I will address them in a future video. Thank you for watching. Please like and subscribe for more.